Hello viewers, welcome to our YouTube channel. In this video, we will demonstrate a turbulent pipe flow problem in ANSYS Fluent. In this video, you will learn how to find the Y plus value in ANSYS Fluent, where to use the k-epsilon turbulence model, how to find the skin friction coefficient. We'll see how you can create a non-dimensional graph using ANSYS CFD post-processing. For simplicity, we have divided the tutorial into two parts. This is the part 1 of the tutorial. In this part, we will demonstrate the 2D pipe geometry creation and meshing. If you are a beginner in ANSYS, then this tutorial will help you to learn the geometry modeling and meshing in ANSYS. Please subscribe to our channel and press the bell icon to activate the channel notifications. This is the pipe geometry. It's a 3 meters long pipe. The diameter of the pipe is 0.2 meter. Select the ANSYS fluid flow from the toolbox, double-click on it, alternatively drag it into the project schematic window. In this, choose the analysis type to 2D, as we are going to do a 2D analysis. Now, right-click on Geometry. Select the second option, that is ANSYS Design Modeler, to create the geometry. Check the default units setting. Keep it as meter. Select the XY plane, click on the Z to make the sketch normal to the screen. Use the mouse scroll to zoom. Use this to scale it nearer to the geometry dimension. Switch to Sketching tab, select the rectangle from the Draw toolbar. Start the rectangle from the origin. Put dimensions to the rectangle. As it's an axisymmetric problem, so we would create half of the pipe geometry. We need to convert this sketch to a 2D geometry. For this, we need to go to the Concepts menu. Here we can get the option Surface from Sketches. Using this option, we will convert the sketch to a 2D geometry. Geometry is complete. Now proceed for meshing the geometry. Open the Meshing Workbench window. In the tree outline, right-click on Mesh. Select Insert, then select Sizing. Select the Edge Selection option. Hold the Control key and select the bottom and top edge. Then click on Apply. Then change the type to Number of Divisions. Put the number of divisions. Change the mesh behavior to Hard, so the mesh will only follow the number of divisions to mesh. Again, select the Sizing. Select the vertical edge. Then click on Apply. Put the number of divisions. Change the mesh behavior to Hard. Bias is used to divide the edge, as per the factor and number of divisions. Select the bias type and put the bias factor. Bias factor 10 means it will gradually increase the divisions up to 10 times of the smallest divisions. Select another edge and put the same number of division. In this case, put the bias type as the reverse of the previous bias setting. This will make the cells to be distributed properly. Before generating the mesh, you can preview the number of divisions on the edge. Right-click on Mesh and select Generate Mesh. It will now mesh the geometry with current sizing input. Insert the face meshing. It will map the cells uniformly over the face. Cells are arranged uniformly as per the biased setting. To observe the mesh quality and aspect ratio, change the display style. It can be seen as a color map. Select the edge and name it as the inlet. Select the bottom edge of the rectangle and name it as the axis. Select the top edge of the rectangle and name it as the pipe wall. Select the edge and name it as the outlet. Right-click on Mesh and Update. It will link the meshed cell with the CFD solver. Simultaneously, you will get an info message regarding successful mesh transition to the solver. Now close the meshing and proceed for solver setup in ANSYS Fluent. In our next part, we would show you the details procedure for solver setup and results analysis in CFD post-processing workbench. You can get the link of the tutorial part 2 in the description. Please like this video if you find it helpful, subscribe to our channel to get information regarding our new video uploads. Thank you.